the teacher!
Hey guys, here's how to calculate a point given a slope and another point. So in the last lesson you knew how to calculate slope if you had 2 points, but now what happens if I gave you slope and one other point? How would you figure out what the other point could be? So if you remember, the formula for slope is I'm going to go back to this one, sorry, is Rm equal to y2 minus y1 over x2 minus x1. We also know that m is equal to rise over run. This one is generally easier to figure out what another coordinate is than this one. So they're both possible to do, but I'm going to show you how to do it with rise over run because it is much easier to do. So let's say that we have a point A at 4 and 7 with a slope of -5 over 3. So if I were to write that in fraction form, this is my rise. So in this case, it's going down 5. And the bottom number is my run, and it's going to the right 3. So what does that mean for our x and y coordinates? That means that for my x value, which in this case is 4, I'm going to make it go higher, because if we think of our Cartesian plane, if you're going to the right, your x values are increasing. They're getting bigger. But, sorry, that's increasing. But if we're going down on a y-axis, your y values are getting smaller. So this 7 is going to go down by 5, and this 4 is going to go up by 3. So very simply, we're going to do 4 plus 3, that's equal to 7. So this is my x coordinate, and 7 minus 5 is equal to 2. So a new coordinate b could then be 7, which was my x value, and 2. And that's it. You can keep continuing this. You would add 3 to this and subtract 5 for this, and you can keep going on and get c values. So this would be 10, this would be -3, and so on and so forth till forever. And that's how you figure out another coordinate using the slope. Now what happens if you actually do want to use the y2 minus y1 formula to figure out what the other endpoint is? So it is possible, if I have my m already, which in this case is -5 over 3, we're just going to use the same example. So -5 over 3 is equal to some y, which we already know. I'm going to just make this my x2 and my y2. So 7 over some y1. 7 minus some y1 over x2, which in this case is 4, minus some x2. So you can also very clearly see that this is my denominator. It has to equal this. And this is my numerator. It has to equal this numerator as well. So you could then rewrite it. I'm just going to make the top purple. So I'll rewrite it in purple. So you can then rewrite your numerator as -5 equals 7 minus y. You're going to use your inverse operations to figure out what the y value is and isolate for it. So I'm going to bring the 7 over to the other side. It becomes subtract -7 on both sides. So -5 minus 7 is equal to -y. This simplifies to -12, which equals -y. And then I always want my y's to be positive. So you can then divide both sides by -1, or just the negative signs cancel out. So I'm going to have y is equal to 12. So that's 1 point. That's our y coordinate. Now you're going to do the same thing for the bottom, which I'm going to denote in blue. So you can say 3 is equal to 4 minus my x2. I'm going to bring the 4 over to the other side by subtracting 4 on both sides. So 3 take away 4 is equal to negative x. Again, I said this before, if you want to switch these and switch all the signs, you could write this if you wanted to as x is equal to negative 3 plus 4. I'm just going to keep it this way, but you can choose whichever method that you like. So 3 minus 4 is negative 1, which equals negative x. I can divide both sides by, oops, that should have been red. I think you guys will understand that. So x is then equal to 1. So I could have some b value where my x coordinate would be 1 and my y coordinate would be 12. And to double check, you can just sub this coordinate, which is my final answer, back into the formula. You should get both sides equal to each other. Left side is equal to right side. And that's how you can figure out what the points are using both ways. Choose the way that you like the best and stick with that way.